Jupiter is a gas giant, the largest of all 8 planets in our solar system in both volume and mass. Although its mass is only about 1,000th that of the Sun, it's still 2.5 times the combined mass of all the other planets, which is astonishing. To truly grasp its scale, imagine a planet so large it could hold over 1,300 Earths inside it. Orbiting this colossal world are 79 moons, each pulled in by Jupiter's immense gravitational force. But what makes Jupiter even more fascinating is that, despite its size and distance from Earth, it has long been considered our planet's silent protector. Positioned just beyond the asteroid belt, Jupiter acts as a massive gravitational shield. Its powerful gravity captures or diverts many of the asteroids and comets that might otherwise drift inward toward the terrestrial planets, including Earth. In other words, Jupiter doesn't just orbit the Sun, it stands guard. Without it, Earth would likely face a dramatically higher risk of catastrophic asteroid impacts. Many of the space rocks that enter the inner solar system are intercepted or deflected by Jupiter's gravity well, reducing the chances they could ever reach us. A striking example occurred on September 13, 2021, when an amateur astronomer from Brazil captured a bright flash on Jupiter's surface, a likely result of a massive object colliding with the planet. It was yet another reminder that, out there in the vastness of space, Jupiter is constantly taking the hits so that we don't have to. By pure chance, that same amateur astronomer ended up capturing a rare impact event on Jupiter. A small asteroid had suddenly slammed into the planet's surface, releasing a powerful flash of light at the exact moment of collision. According to astronomers, the impact was immense. The explosion covered an area nearly half the size of Earth. Had that asteroid been heading toward us instead, the consequences would have been unthinkable. And while this particular event wasn't the largest ever observed, many still remember the catastrophic impact of 1994, the Shoemaker-Levy 9 collision, the most powerful planetary impact ever recorded in human history. Back then, a comet named Shoemaker-Levy 9 was captured by Jupiter's gravity. As it approached within 40,000 kilometers of the planet, the comet was torn apart by tidal forces into 21 massive fragments. The largest of those fragments measured nearly 4 kilometers in diameter, and together they stretched in a chain over 160,000 kilometers long. Each of those pieces then slammed into Jupiter's southern hemisphere at a speed of 60 kilometers per second, leaving behind a trail of scars visible for months. Scientists later calculated that the total energy released by the impacts was equivalent to 400 trillion tons of with the most powerful single fragment unleashing over 6 trillion tons of explosive force, roughly 750 times the combined power of all the nuclear weapons on Earth. The scars left on Jupiter's surface were so enormous, some were larger than the diameter of Earth itself. It's terrifying to imagine what might have happened had Shoemaker-Levy 9 struck Earth instead. A collision of that magnitude would have triggered global earthquakes, massive tsunamis, and violent volcanic eruptions. The dust and debris thrown into the atmosphere could have blocked sunlight for years, collapsing ecosystems and driving most life on Earth into extinction. In fact, the apocalyptic scene would have looked eerily similar to what happened 65 million years ago, when a much smaller asteroid wiped out the dinosaurs. Fortunately for us, Jupiter was, and still is, there to take the hit. According to computer simulations, without Jupiter, Earth's chances of being struck by a catastrophic asteroid could be up to 1,000 times higher. That means Jupiter may be one of the main reasons why complex life was even able to evolve on our planet in the first place. While we look to the stars in wonder, it's easy to forget, if not for Jupiter, we might not be here at all. A thunderous roar echoed across the sky, marking the beginning of a new journey into space. Astronauts Ni Haisheng, Liu Boming, and Thames Hongbo lifted off aboard the Shenzhou 12 spacecraft, headed for the Tiangong space station during their 3-month stay in orbit. The crew carried out a wide range of tasks, from external maintenance and equipment replacements to scientific experiments and system tests. On September 17th, after successfully completing 90 days aboard the station, the trio safely returned to Earth, touching down at the Dongfang landing site in what was considered a flawless mission. Many around the world watched the live stream of their return, and one image stood out. The astronauts lying on special reclined chairs immediately after landing. That left many people wondering, why do astronauts always lie down or sit when they return to Earth? Is it some kind of special treatment? The answer is no. This isn't luxury, it's recovery. In fact, it's a sign of the immense physical toll that space travel takes on the human body. Space and Earth are drastically different environments. The Tiangong space station orbits about 400 kilometers above Earth in a microgravity environment, where astronauts experience near weightlessness for extended periods. In such conditions, the human body undergoes profound changes. Muscles weaken, bones lose density, and even blood distribution shifts. Unlike people on Earth, whose muscles and bones are constantly resisting the pull of gravity, astronauts in space no longer need to exert force just to stay upright, and over time, their bodies adapt in ways that make returning to normal gravity a challenge. That's why, after long missions, astronauts are often unable to walk right away. They sit or lie down, not because they want to, but because their bodies need time to readjust to Earth's gravity. Over time, the human body naturally adapts to Earth's gravity. Our muscles, bones, and cardiovascular system are constantly working to counteract it. But once astronauts enter the microgravity environment of space, everything changes. Their bodies no longer need to fight against gravity, and as a result, they remain in a state of complete relaxation. This long-term weightless freedom causes the body to gradually weaken. One of the most serious effects is bone loss and muscle atrophy. Without regular resistance, bones begin to lose density and muscles shrink, especially those used for posture, movement, and balance. That's why, in nearly every footage we see from space stations, astronauts are shown exercising regularly. Special equipment, like resistance machines, stationary bikes, and treadmills strapped with harnesses, is installed specifically to counteract the effects of microgravity. These workouts are not for fitness, they're for survival. Even with daily training, after living in space for weeks or months, the body becomes accustomed to weightlessness. So when astronauts suddenly return to Earth's gravity, the transition is physically demanding. It becomes difficult, sometimes impossible, to stand or walk immediately. That's why recovery protocols are carefully planned before landing. Astronauts are provided with reclined seats to reduce stress on their bodies, and after returning, they undergo intensive rehabilitation and physical training, often lasting weeks or months, to restore muscle strength, balance, and skeletal integrity. So, those reclined chairs you see during re-entry aren't a luxury, they're a necessity, earned through incredible sacrifice and scientific precision.